Good morning, all. Myself is Vigneshwari, Assistant Professor in the Department of Electronics and Communication Engineering from SNS College of Technology. So today I am going to discuss on the topic comparison of common base, common emitter, common collector configuration and current amplifying factor of the unit bipolar junction transistor. So this comes under the subject basic electrical and electronic circuits. So let's recall with the previous topic. So a transistor has three terminals, namely emitter, base and collector. The emitter emits the charge carrier and the base controls the carriers and the collector region that collects them. So the important current relationship in a transistor is IE is equal to IB plus IC. So where IE is the emitter current, IB is the base current and IC is the collector current. Now, depending on which terminal it is being connected to both input and output, the transistor operates in different configuration. So in today's discussion, we are going to look about common base, common emitter and common collector configuration. So all these three configuration comparison, current amplifying factors and relationship between alpha, beta, gamma and importance of these configuration we are going to discuss in detail. So first, why do we need such configuration? So different specifications of application, they require different characteristics. For example, some circuits need a high voltage gain, where some needs a high current gain and some require impedance matching and some operate at high frequencies. So the transistor configuration helps us achieve all these requirements. So common base configuration is useful in high frequency application and common emitter configuration provides good voltage and current gain. So it is widely used in amplifiers. Common collector configuration provides high input impedance and low output impedance, making it suitable for buffer circuits and impedance matching. Right, so selecting all these correct configuration, it improves the circuit efficiency and performance. So overall, for high frequency application we go with CB, and for a good voltage and current gain for amplifiers we go for common emitter, and the common collector, it provides a good impedance matching. So what is that current amplifying factor, right? So current amplifying factor is defined as the ratio of the output current to the input current, and that indicates the amplifying capability of the transistor. So in common base configuration, we refer it as alpha, and for common emitter, we refer it as beta, and for common collector, we refer it as gamma. Current gain in common base, common emitter and common collector. So in common base configuration, the collector current, that is a current amplifying factor alpha, is equal to IC by IE. So its value is slightly less than 1 and it ranges usually between 0.95 to 0.99. So that means there is no significant current amplification, but it provides a high voltage gain as well as at high frequencies. Common emitter configuration, the value beta, it is given by IC divided by IB, where its value is a high generally between 20 to 200. So since a small base current controls a larger collector current, common emitter configuration provides excellent current amplification factor. So that is why CE is commonly used for the amplifying applications. Common collector configuration, where gamma, its value is very high, where voltage gain is also nearly equal to the 1 because of the maximum current gain, and that's why this is mainly used in the buffer circuit. So here you can see the comparison chart where the current gain in common base configuration is low, and for common emitter it is high, and for common collector it is very high. So the current gain, it slowly improves, right? And the voltage gain, it starts to degrade. In common base, common emitter it is high, and for common collector it is low. Input impedance is common base, it is low, common emitter it is medium, and for common collector it is low. And phase shift, for common base and common collector there is no phase shift, whereas in common emitter it has a 180-degree phase shift. And what are all the key observations we could see here is in common base it does not provide a current amplification but provides a good voltage gain. In common emitter configuration, it provides both the current as well as the voltage gain, making it best for general purpose amplifier. In common collector configuration, it is excellent for impedance matching. Advantages and application. It has a high current gain and fast switching response, and mainly they are used in audio amplifier, RF amplifier, oscillators, as well as switching and the digital circuit. So let's summarize. BJT has three configuration: common base, common emitter and common collector. A common emitter is used for amplifier and common collector is used for impedance matching, and common base is preferred for high frequency application. So we could see a short quiz over here. Which configuration has the highest current gain? Common collector. And which configuration is also known as an emitter follower? That is common collector. So these are the references. Kindly watch my next videos also. Thank you.